Welcome back to the channel. I am Undasan Worku and today we are breaking down regular polygons into simple, easy to understand maths. Have you ever wondered how to find the area of a shape with 8, 10 or even more sides? The secret is not a massive, complicated formulas. It is actually just breaking the shape down into equal triangles. In this video, I am going to show you how to use a single right triangle and the tangent functions and the optimum to solve this step by step. We will even walk through a complete examples using a regular octagon. Let's dive right in. A regular polygon is a many-sided shape with a very strict kind of balance, and the goal is to see how that balance controls its sides, angles, symmetry, and area. We will start with the definition, then connect side lengths to perimeter, build the angles, formulas from triangle in a full turn, describe reflection and rotation symmetry, and finish by using the optimum to find area. The first step is to pin down exactly what makes a polygon regular. To begin the plan, a polygon must first be a closed, flat shape made only from straight line segments. It is irregular only when all side lengths are equal and all interior angles are equal. With equal sides established, the number of sides can be named n, where n is an integer, at least 3. If each side has length s, the perimeter is n times s. Now that the sides form vertices, each vertex has an interior angle inside the polygon and an exterior angle formed by extending one adjacent side. Because these two angles make a straight line, their measures add to 180 degrees. With the interior angles identified, a polygon with n sides can be divided from one vertex into n minus 2 triangles. Since each triangle has 180 degrees, the total interior angle sum is n minus 2 times 180 degrees. With the total interior angle sum known, regularity lets the total be shared equally among all n angles. One interior angle is n minus 2 times 180 degrees divided by n, because the exterior angles of any polygon make one full turn. Their total is 360 degrees. In a regular polygon, they are all equal. So one exterior angle is 360 degrees divided by n. For a regular hexagon, n equals to 6. So the total interior angle sum is 6 minus 2 times 180 degrees, which is 720 degrees, or the result is 720 degrees. Dividing by 6 gives one interior angle of 120 degrees, and 360 divided by 6 gives one exterior angle of 60 degrees with equal sides and equal angles. A regular polygon also has mirror balance. A regular polygon with n sides has exactly n lines of reflection symmetry. That same balance also appears when the polygon turns around its center and lands on itself again. Its order of rotational symmetry is n, and the smallest matching turn is 360 degrees divided by n. To prepare for area, the optimum is the perpendicular segments from the center of a regular polygon to the midpoint of a side. It also acts as the radius of the inscribed circle and cuts that side into two halves. With the optimum reaching each side, the polygon can be split into n matching triangles. each with base S and height equals to the optum. Adding their areas gives area equals to 1/2 times the optum times the perimeter. Putting the pieces together, regular polygon have equal sides, equal interior angles, predictable symmetry and area built from the perimeter and the optum. The key formulas are perimeter equals to n times s, 1 interior angles equals to n minus 2 times 180 degrees divided by n, 1 exterior angle equals to 360 degrees divided by n, and areas equals to 1/2 times optum times perimeter. A regular polygon is a many-sided shape with a very strict kind of balance, and the goal is to see how that a regular polygon is a many-sided shape with a very strict kind of balance, and the goal is to see how that balance controls its sides, angles, symmetry and area. We will start the definition. A regular polygon can be measured by breaking it into equal triangle from its center, then using one small right triangle to connect the side lengths and the optum and the area. First, the optum will be found with tangent, then the perimeter will be calculated from the number of sides and side lengths, and finally, those pieces will be combined in the regular polygon area formula. The regular octagon gives a clear examples because its 8 equal sides create 8 matching center triangles. To begin the plan, a regular polygon is divided by connecting its center to every vertex, creating one congruent isosceles triangles for each side. In a polygon with n sides, each central angle is 360 degrees divided by n. With the central angle identified, the optum cuts one isosceles triangles into two matching right triangles. The side length is split into halves, and the angle at the center becomes 180 degrees divided by n. Now that the right triangles is formed, tangent connects the angle to the opposite and adjacent legs. Tangent of 180 degrees divided by n equals side lengths over 2 divided by the optum, with the tangent written as a ratio. The equation can be rearranged so the optum is unknown. The optum equals to the side lengths over 2 times the tangent of 180 degrees divided by n. For the regular octagon, n is 8 and the side length is 6 centimeter. So the angle in the tangent is 180 degrees divided by 8. The optums equals to 3 divided by tangent of 22.5 degrees. Using tangent of 22.5 degrees as about 0.4142, the optum expressions becomes 3 divided by 0.4142. The optum is about 7.243 centimeters. With the optum known, the area formula also needs the total distance around the polygon. 8 sides of 6 centimeters gives perimeter of 48 centimeters. Since the regular polygon is made of n congruent triangles, each triangle has base side lengths and height optum. Adding all the triangle areas gives 1/2 times the perimeter times the optum. With the perimeter and the optum ready, substitute 48 centimeters and about 7.243 centimeters into 1/2 times perimeter times optum. The area of the regular octagon is about 173.83 square centimeters. Thank you for your attention.